Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually discussing the 7th chapter of 9th standard science subject, that is motion. So in previous videos, we have learnt about speed, velocity, acceleration, distance, displacement, etc. So in this particular video, we will be discussing the equations of motion which are actually given. So the derivation of this particular equations of motion you will be learning in your higher classes. So in this particular chapter or in this particular level, you can just remember the equations of motion so that using those equations of motion, you can actually solve the problems which are given in this particular chapter. So the first equation which we have here is V is equal to U plus AT. So here V actually represents the final velocity. So always you should remember when the motion is about to end at a particular point. So what was the velocity at that particular point? So let's say if a particular vehicle or a particular object is moving from point A to point B, so it will be moving in a straight line. So on that straight line, we are taking 2 points. So let's say point A and point B. So whatever the physical quantities you have to calculate from point A to point B, that is if you want to calculate acceleration or distance or time or velocity. So at that time, the initial velocity, the velocity which at that particular object was traveling at point A will be your initial velocity, that is U, and the point B. So the final point which you are actually considering while calculating the physical parameters. So that particular final point, whatever the velocity of that particular object is, that will be the final velocity. So V will be final velocity and U will be the initial velocity of a particular object. Here you have another term A. A is simply acceleration and distance is actually represented as S. So here S represents distance. So in the first equation, you have the relationship between the velocity and time. So using this particular first equation, you can actually calculate initial final velocity and also time taken, and also using this equation you can get an idea about acceleration, and in this equation you can also get idea about initial velocity. So in second equation, you will be actually comparing the distance traveled and the time taken and also acceleration. So in this particular second equation, you will be having acceleration, initial velocity, distance and time. So here you should see these equations, and when you get questions or when you get problems related to equations of motion, at that particular time, what physical quantity you have to calculate based on that, and what data you have in your hands, based on that you should use one of these equations. For example, if in a problem they are asking you to calculate the total distance, they have not given initial final velocity, but they have given initial velocity and acceleration. So at that particular time, even though you don't have final velocity, you can calculate the distance covered, because here in this particular second equation, final velocity is eliminated. So final velocity is not required in calculating the total distance traveled. So now here they will give another problem where there will be final velocity and also initial velocity given, but they won't give any kind of time taken for traveling that particular distance. So now you have to find the total distance traveled. So at that particular time, you can use this third equation, where in this particular third equation, time is actually eliminated. So you can see here in third equation, time is not there. So you should always remember time is not there in third equation. So in first equation, you can clearly see here distance is not there. So now if they are just asking to calculate some final velocity or the initial velocity where they have given acceleration, so at that particular time you can just avoid the total distance and use this first equation to calculate the final velocity. So always by looking at these equations, you should see the problem, you should see the question and analyze whatever data you have. So based on the availability of data, you can actually use one of these equations. So you cannot use all the equations because sometimes certain physical quantities might not be given. So that means here you should just remember these three equations. So derivations you will be learning in your higher classes. So how to derive these particular equations of motion. So as of now, you can just remember these equations of motion, and you should look at the problem and see what and all things are there and what you have to calculate. Based upon that particular knowledge, you can use one of the equations out of these equations of motion. So based on these equations of motion, based on these three equations, they have given three examples in this particular chapter. I'll be going on discussing each example now. And always you should remember, these particular equations will be applicable only for a system which has uniform motion or uniform acceleration. So always you should remember, uniform acceleration should be there. So if a particular system is not moving in an uniform acceleration, then you cannot use these particular equations. So if you are calculating any of the parameters using this particular three equations, then you should always remember the system or the object of motion which you are actually considering is moving in an uniform motion or in an uniform acceleration or not. So this particular equations will be applicable only if a system is in uniform acceleration. So if a particular object or a vehicle is moving with non-uniform acceleration, then you cannot use these particular equations. So this is one point which you can actually remember before solving any kind of problems. So coming to the example 7.5 in this particular chapter, here they have given a uniformly accelerated system. They have given a train is actually traveling. So that particular train is actually uniformly accelerating. So initially this particular train was at rest. So that means here they have given u, that is initial velocity. So initial velocity was, train was at rest. So that's why initial velocity will be 0. So now they have given the final velocity as well. So this particular train will actually accelerate uniformly and reach a particular final velocity. So that particular final velocity is 72 kilometer per hour. So this is the final velocity what this particular train reaches. So now after this, they have also given the time to reach from this 0th velocity to 72 kilometer per hour velocity. So starting from rest to reach 72 kilometer per hour speed, this particular train is actually taking 5 minutes. So time will be equal to 5 minutes. So these are all the parameters which they have given in this particular problem, which I am actually extracting, so that you can actually look at the equations, those three equations, and whatever the data they have asked and whatever the answer they have asked, whatever the physical quantity they have asked to calculate. So based on the data given, you can choose one of the equation. So now they have given initial velocity, they have given final velocity, and they have given time. And here you should actually calculate the acceleration. So the first question in this particular example is to calculate acceleration. So what will be the acceleration? And the second question what they have asked here is distance traveled to attain this final velocity. So the distance traveled by the train for attaining this velocity. That means at a particular position it was at rest, that is the initial velocity will be 0, and at a particular position it has attained velocity 72 km per hour. So let's say this is a particular point where train is actually starting. So at this particular point the velocity was 0, and at this particular point the velocity will be 72 km per hour. So how much distance it has traveled for 5 minutes by accelerating uniformly to reach this particular distance? So this is actually the distance, yes. So this will be your second question. So here you should actually calculate the acceleration of that particular train to reach 72 km/h from 0 km/h. That means from rest to reach 72 km/h velocity, how much acceleration, how much uniform acceleration that train has underwent, and how much distance it has covered to reach that 72 km/h velocity. So it has reached some distance, no? That distance you should actually calculate. So that will be the second question in this particular example. So now you have initial velocity, you have final velocity, and you have time. So which equation you can actually use here? Here in the first equation, you can actually use this particular first equation. You cannot use second equation, because in second equation you have initial velocity, you don't know what is acceleration, and you also don't know what is distance. So because you don't know what is distance, you cannot use the second equation. But in first equation, apart from this acceleration, you know what is the time, you know what is the initial velocity, and you also know what is the final velocity. So easily you can use equation 1 and you can calculate the acceleration. But in equation 2, you don't know acceleration and you don't know distance. So both the parameters are there in that particular equation 2. So if you use equation 2, you have to get the distance to calculate acceleration, or to know distance you should be knowing acceleration. So that's why to calculate answer for the first question, that is to calculate acceleration, you should actually use this first equation, that is v is equal to u plus at. So here the equation 1 is v is equal to u plus at. We know that in this particular question u is actually 0, because here you can see train was at rest, so that's why initial velocity will be 0 and final velocity is 72 km per hour. So now we can use the first equation, that is v is equal to u plus at. Here u is actually 0, v is actually 72 km per hour. So always you should remember, any calculation, while doing any calculation, you should actually take the SI units of that particular physical quantity. So here velocity, they are giving kilometer per hour as the unit. So you should convert this to SI unit. So what is the SI unit of velocity? That is in meter per second. So now this velocity, if you convert into meter per second, so you should remove this kilo. So in the place of kilo, you can write 10 power 3 meter, and in the place of per hour, you can write this as 3600 second. So now 72 divided by 3600 is there. So here you have 72 into 10 power 3, that is actually 1000. So 72 into 1000 will be 72,000 meter divided by 3600 seconds. So here 10, 10, 10, 10 gets cancelled with each other. So here 36 ones are 36, 36 twos are 72, and one more 0 is there, so 20. So here final velocity will be 20 meter per second and initial velocity is equal to 0. Now you can calculate acceleration. So what is the equation which we have? V is equal to u plus at. So here in the place of t, you have to substitute the time. So here time they have given in minutes. So this also should convert into SI unit. So that means you should convert this to seconds. So 1 minute is equal to 60 seconds. So for 5 minutes it will be 5 into 60 seconds. So what is 5 into 60? 5 into 60 will be 5 6 are 30, 1 0 is there, so 300 seconds. So time will be equal to 300 seconds. So now I have converted everything in SI units. We can just substitute in this particular equation and calculate the acceleration for this. So final velocity is actually 20 meter per second and initial velocity is 0, plus acceleration we have to calculate, and time is 300 seconds. So since it is 0 plus a into 300 seconds, so it will be a into 300 seconds on the RHS, and in LHS it will be 20. So if we bring this 300 to LHS, it will go to the denominator. So 20 divided by 300 will be equal to a. So here 1010 gets cancelled, 2 ones are 2 15s are will be remaining. So here acceleration is equal to 1 by 15. Here this was in meter per second. So here the unit of this velocity is meter per second. So in the numerator meter per second will be there, and in the denominator second will be there. So that means when you bring this per second also to denominator, it will be second only, because it is per second. So you should put that in denominator. So 1 by 15 meter by second into second. So second into second will be second square. So meter per second square is the unit for acceleration. So 1 by 15 meter per second square is the answer for your first question. So here you are getting acceleration as 1 by 15 meter per second square, or you can write this as meter into second power minus 2. So coming to the second question in this particular example, there you have to calculate the total distance traveled by the train to reach that particular final velocity. So now you have acceleration and you also have initial velocity, final velocity, and also you have time. So directly you can use the second equation, because here you already got acceleration. So you can directly use second equation, where second equation is S is equal to ut plus half at square. So here u is initial velocity, so s will be equal to 0 into t, because initial velocity is 0, plus half at square is there. So now 0 into anything will be 0, so this term will become 0, and only half AT square will be remaining on RHS. So that means here distance S is equal to half AT square. So what is acceleration which we have got? That also we have got in SI unit only. So that is 1 by 15 meter per second square into what is the time we have here? 300 seconds. So it is T square. So 300 square will be there. So 15 into 2 will be equal to 30. So 1 by 30 will be there. Here instead of writing 300 square, I'll write 300 into 300. So here 30 ones are 30, 30 tens are 300. So 10 into 300 will be 3000 meter. So 3000 meter is the distance. Because why I am taking meter is because here you are taking time square. So time square means here it will be second square, and here you are taking acceleration. So that will be in meter per second square. So here second square cancel and only meter will be remaining. So that's why 3000 meter is your distance. If you want to convert this into kilometer, then you can write this as S into 10 power 3 meter, or you can write this as 10 power 3 you can write as kilometer, so 3 kilometer. So that means after 3 kilometer this particular train has reached that final velocity, that is 72 kilometer per hour. So S is equal to 3000 meter or 3 kilometer is the answer for your second question in this particular example. So coming to example 7.6. So here also in this particular example 7.6, they have given an uniformly accelerated system. So here car was at 18 km per hour speed and it has reached 36 km per hour speed after some time. So that means here it has uniformly accelerated from 18 km per hour to 36 km per hour in 5 seconds. So that means here they have given initial velocity and they have given final velocity and also the time. Here also the acceleration is uniform, because these three equations you can apply only for an uniformly accelerated system or uniform motion system. So now here the car is uniformly accelerating. Since it is uniformly accelerating, we can use one of the equations in this particular three equations to calculate the physical quantity which they have asked. So in example 7.6, you have initial velocity as 18 km per hour. So you should convert this kilometer per hour into meter per second. And they have given the final velocity, that is 36 km per hour. And also they have given time here. So time is actually equal to 5 seconds. So now you can convert this initial velocity into meter per second. So initial velocity is equal to 18 km per hour. So when you convert this 18 km per hour into meter per second, so it will be 18 into 1000 meter divided by, in the place of hour you will be writing 3600 seconds. So here 0, 0, 0, 0 gets cancelled with each other. So here 18 ones are 18 twos are 36, 2 ones are 2 fives are 10. So here 5 meter per second is the initial velocity. Now if you want to calculate final velocity, so final velocity is 36 km per hour. So here to calculate 36 km per hour, to convert this 36 km per hour into meter per second, you can actually multiply this with 1000. So 1000 meter divided by, in the place of hour you will be writing 3600 second. So here also 0, 0, 0, 0 gets cancelled. So 36 ones are 36 ones are. Only 10 will be remaining. So 10 meter per second. So now in terms of SI unit, you have initial velocity as 5 meter per second and final velocity as 10 meter per second. So using this particular data, you can actually calculate the acceleration. So the time what they have given here is 5 seconds. So this is already in SI unit, so no need to convert this. So you can use the first equation itself. So the first equation to calculate the first question. So first equation is V is equal to U plus AT. So what is V? V is final velocity, that is 10 meter per second. So 10 is equal to U is 5 plus A you don't know. T is, that is time, is 5 seconds. So you can bring this 5 to LHS, so it will become minus 5. So 10 minus 5 will be equal to A into 5. So 10 minus 5 will be equal to 5 is equal to A into 5. So when you bring this into 5 to LHS, it will become divided by 5. So 5 divided by 5 will be equal to A. So 5 ones are 5, 5 ones are 5. So here A will be equal to 1 meter per second square. So here 1 meter per second square is the answer for acceleration. So for the first question. So now we have to calculate the total distance traveled by this particular car from reaching 18 km per hour speed to 36 km per hour. So now acceleration you have got as 1 meter per second square, and here you have initial velocity as 5 meter per second, and you have final velocity as 10 meter per second, and time is actually equal to 5 seconds. So straight away you can use the second equation. So s, that is the distance, is equal to ut plus half at square. So you can substitute in the place of u, because u is initial velocity, you can substitute 5. So 5 into time is 5 seconds, so 5 into 5 will be there, plus half into a is 1 meter per second square, and time is 5 seconds, so 5 square will be there, because here we are taking t square. So now to calculate distance, you can just go on calculating this. So 5 into 5 will be 25, plus 1 by 2 into 5 into 5 will be 25. So what is 25 divided by 2? 25 divided by 2, this is actually 1 by 2 into 25. So 25 divided by 2 will be 12.5. So 25 plus 12.5 will be there. So s will be equal to 37.5. Everything we have taken in SI unit, so distance will also be there in SI unit only. So that is meter. So 37.5 meter is the answer for second question in this particular example 7.6. So acceleration is 1 meter per second square, and the distance traveled to reach the final velocity from the initial velocity is 37.5 meter. So coming to the next example in this particular chapter, that is example 7.7. Here they have given a particular car, in a particular car suddenly brake is applied. So that means here 6 meter per second square acceleration is applied to the opposite direction of motion. That means here deceleration is actually taking place. So that means if a car is traveling at certain speed, and if suddenly brakes are applied, then this particular acceleration acts opposite to the motion. So when accelerator is pressed, then acceleration will be acting towards the direction of motion, but here brakes are applied, so the acceleration will be opposite to the motion. So for example, if this is the direction of motion, then acceleration will be acting opposite to that particular motion. So here the value which they have given for acceleration in opposite direction is 6 meter per second square, and time taken to reach, to make that particular car to stop. So here they are actually giving the final velocity as well. So here car has come to rest after applying brake. So initially it was actually traveling in a certain speed, and after applying 6 meter per second square acceleration in opposite direction of motion, that means after applying the brake, here car has come to stop. So that means the final velocity will be equal to 0. So in this particular case, final velocity is equal to 0, and the time taken to achieve this is 2 seconds. So time here is 2 seconds. We don't know what is initial velocity. So now you should actually calculate the distance traveled during this particular time. So here, if you use the second equation to calculate distance, so that is actually s is equal to ut plus half at square. So here you should remember, you don't have this particular initial velocity. They have given car has come to rest. That means they have given final velocity. But u, that is the initial velocity, they have not given. So to calculate distance, you want this initial velocity as well. So to get initial velocity, you can use the first equation. That is v is equal to u plus at. So before substituting these values in this particular equation, you should always remember here acceleration is applied in the direction opposite to the motion. So that means it has the acceleration is acting negative to the direction of motion. That means here acceleration should be taken as negative, because the direction of acceleration is opposite to the direction of motion. Only when the acceleration is in the direction of motion, then the acceleration will be positive value. But if the acceleration is applied, that means if brake is applied, then that is actually applying acceleration in the opposite direction to the motion. So that means here acceleration will be negative. So in the place of 6 meter per second square, you can take minus 6 meter per second square, and you can substitute that in this particular equation. So here final velocity is 0. So in the place of v, I will substitute 0, and in the place of u, we don't know what is u, so we will keep u as it is. Plus in the place of a, we can take minus 6 into, in the place of t, you can take 2 seconds. So that means here 6 into 2 will be 12. So u minus 12 will be there. And if you bring this 12 to LHS, it will become plus 12. So u is equal to plus 12. That means here initial velocity is 12 meter per second and final velocity is v is equal to 0, because here everything we are calculating in SI units. Here acceleration is also in SI unit, that is meter per second square, and also time is in SI unit, that is seconds. So that's why even the velocity which we are calculating here will also be there in SI unit, that is meter per second. So the initial velocity here is 12 meter per second. So now we have initial velocity as 12 meter per second, which we have calculated, and final velocity as 0, and acceleration as 6 meter per second square, and we have time that is equal to 2 seconds. So now you can use this equation 2, that is the second equation of motion. S is equal to ut plus half at square. Now we have all the parameters to calculate this particular distance traveled. So S is equal to ut. In the place of u you can substitute 12, and in the place of t you can substitute 2 seconds, because here time they have given as 2 seconds. So in the place of t you can substitute 2. So 12 into 2 will be there. So 12 into 2 plus half into at square. So what is acceleration? Acceleration is 6 meter per second square, but this particular acceleration is in the opposite direction of the motion, because here you are applying brake to make that particular car come to rest. So that's why here in the acceleration we have to take minus 6 meter per second square. So in the place of acceleration I can take minus 6 into t square is there, so that is 2 square. So now S is equal to 12 into 2 will be 24, and 1 by 2 is there, minus 6 is there, into 2 is there, into 2 square is there. So 2 2s are 4. So here minus 6 into 4 will be minus 24. So S is equal to 24 plus 1 by 2 into minus 24 will be there. So now we have got S is equal to 24 plus 1 by 2 into minus 24. So what is minus 24 divided by 2? It will be minus 12. So 24 plus minus 12 will be there. So that is actually 24 minus 12. So when you do 24 minus 12, it will be 12. Everything we are calculating in SI unit, so distance will also be there in SI unit. So 12 meter is the answer for the total distance covered by that particular car. So that means after applying brake, it has taken 2 seconds and that particular car has traveled 12 meter to come to rest. S is equal to 12 meter is the answer for this particular example 7.7. So this is all there in this particular video. I have taught most of the concepts which are there in this particular chapter. So there is one more concept in this particular chapter, that is uniform circular motion. So this particular concept I will be teaching in my next video. Till then, if you want to learn more physics, chemistry and mathematics like this starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.